Good. So here's a question. The integral from, let's say, 1 to 2 from e raised to x to the third dx. I'm just curious, and we're going to plug this in the graphing calculator just later on in a minute. I have to, in order to determine this, I have to find the antiderivative and then evaluate it from 1 to 2, and it will be the antiderivative 2 and the minus the antiderivative of 1. I cannot find this f of x. Maybe the calculator will give us some sort of approximation. Who knows what the calculator is doing? I can't say. But even if my life would depend on it, I cannot give you this function. I have to use a calculator, maybe, or a computer algebra system, or a software. By hand, I am not capable of determining a function whose derivative is e to x to the third. I am not. I don't know anyone who is, other than a software. So I can still approximate it. And I'm going to say approximated with, let's say, 4 subintervals and the leftmost point. I can still get an approximation. It will be a rough approximation because I'm only using 4 subintervals. If I could use, let's say, 32 subintervals, it would be better. But I'm going to spend my life, right, for the next 3 days to find this with 32 subintervals. I'm kidding, not that much. But I'm going to do it only with 4 subintervals, so I'm going to get a number. It's still not nowhere near exact, right, because I'm using 4, but I can still get an approximation. That's why we need to learn how to approximate these integrals, definite integrals, or areas, or total cost, or total profit. That's what we're looking at, even if I cannot find the antiderivative. Very good question. So, because we are here and we're talking about it, why not? I am just super, I never really use this. Just with you, I do. So, math, I even have to look and see where the, okay, number 9, because I'm not using it myself. So let me see. I am just super curious now what the calculator may scream at me error, or who knows, because you may not be able to do it. Hold on. Yeah, we'll see. Very good question. Okay, so we came up with something. Excellent, but it's an approximation. I don't think that this calculator is equipped to find the antiderivative of e to x to the third. I just think that it's using that approximation that we are using with, I don't know how many subintervals. Okay, but I will not be able to give you the antiderivative. So we can still approximate, and let me put it in. What was it again? 275.51. So we can still approximate when I determine using for the area or the interval or the definite integral with 4 subintervals. I'm not going to get this. I'm going to get close, but not exactly what the calculator is given. And I cannot determine exact anyway. Good. Is this clear? Very good question, Eb. Thank you.
Thank you.
But is it clear why we do this? We learn this, right? Okay.
Yes.
Yeah, so we
Thank
can
you.
still have an approximate cost or approximate revenue or approximate this and approximate that. But whenever we cannot find the antiderivative. Okay, so what I would like to look at, we are back to page 425. Yes, any question?
I had a homework question.
Yes, I'm ready for the homework question.
For 68, the last problem on the homework.
Okay, page or something.
Yeah, I don't even remember. I think.
Which section for that?
4 dot,
It was page 415.
415.
I
Okay.
just do the problems.
Okay, let's take a look. 415, problem 68. 68. 68. I got it. The industrial learning curve. Okay, so we are given the function t of x. Is this the one? 2 plus 0.3, 1 over x?
Yeah.
Okay. Where t is the time. Good.
Yeah, I kept getting negative times for some reason. I don't know.
Yeah, let's take a look. Time in hours. Required to produce the x unit. Okay. So x unit in units. Use this information for exercise. Okay. Find the total time required for a worker to produce units through 1 through 20. So we have the integral from 1 to 20 from t of x dx. And we have the integral from 20 through 40 from t of x dx. Do we need to do both or one or the other, or?
I mean, one would just be fine because they're both the same.
Okay, so the integral from 1 to 20 from 2 plus 0.3 over x dx. So please remember always, like I say, limit, 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 don't drop it, whatever. In this case, I will always say you have to have the integral symbol. You have to have the lower limit of the integral. You have to have the upper limit of the integral. You have to have the function, and you have to have dx. Do not write this, please. This is not an integral. Now it is. Okay, perfect. So now we find the antiderivative. For this function, I can find this. I can. For this one, I cannot. Okay, so then we have 2x, and we have plus 0.3 natural log of the absolute value of x from 1 to 20. Is this okay? Is this okay so far?
Yeah, I realize what I did wrong now.
Okay. Do I continue or not?
You don't have to, but if you want to finish it, because you started it, but
Good. So we have 40 plus 0.3 natural log of 20 minus when I plug in 1 minus when I plug in 1, but it's 0. So the answer will be 38 plus 0.3 natural log 20. Is that better now?
yeah.
Perfect. Good question. Anything else you would like to ask from anything you worked on, anything you want to ask, anything? Okay, in that case, I'll jump. Which page was that? Page 425. Oh, I have a chat. Thank you. Oh, okay. Thank you. Oh, yes, I always do that. Why do I do that? Nobody knows. Okay, so I want us to find area enclosed by graphs. That's our next step. And as I said, 425, 425, enter. Good, done. So, see, here we have an area enclosed, if you want, or the area under or above the x-axis. But here we have two different graphs. Forget about the x-axis. Obviously, we've been doing this, the integral from -1 to 1 from this function. But here we have two different graphs. We have a blue graph, which is called g of x, 4x plus 3. And we have a purple or red graph, which is x cubed plus 3x squared minus 9x minus 12. They are telling us that these two graphs intersect at this point of -5 for x, -17 for y. They also intersect at the point -1, -1. and they also intersect at the point 3, 15. So is it okay if we work on problem 12, or you can choose? So there are others here. But I would like to look at this because this is different than all the other examples. So I'm just going to copy roughly a rough graph. So I'm going to copy this. So this is our f of x, and that is x to the third plus 3x squared minus 9x and minus 12. And the straight line in green. Of course, my graph is not perfect. So g of x, which is 4x plus 3. And I also have to copy those points of intersection. So one of them is -5, -17. The other one, -1, -1. Both of them, yes, correct. And the last one, 3, 15. And we are asked to determine this area as well as this area. Okay. So from the very first piece, I noticed that the polynomial function, degree 3, is above the graph of the line, above 4x plus 3. But on the second piece, it shows that the line is above the piece of the graph from the cubic function. So when I determine these areas, so if I want the exact area, that will be composed by a sum of two integrals. One is from the function above minus the function below, f of x minus g of x. F of x minus g of x. Of course, dx cannot disappear or not be there. From which x value? Can anyone tell us from which x value till which x value? We're only talking about x values.
-5 to -1.
Of course. Excellent, thank you. Now here, from the function above, which is g of x, minus the function found below, which is f of x, of course dx, from which x value till which x value? Anyone?
-1 to 3.
Very good. That's it. So this is how we find areas enclosed by curves or functions. So how will I continue? I'll just plug in the functions, simplify. So I have from -5 to -1 from x to the third plus 3x squared minus 9x minus 12. Careful, minus 4x minus 3 dx plus the integral from -1 to 3 from 4x plus 3 minus x cubed minus 3x squared plus 9x and plus 12 dx, of course. These are all polynomials. We can always determine antiderivatives for polynomials. There is no problem here at all. So let's proceed.
I have a quick question.
Yes?
Why did you subtract them again?
Very good question. Very good question. Let me explain, I'll come back. Awesome question, thank you. So let's suppose I have this graph as f of x. And let's suppose I have this graph as g of x. And let's say I want to determine this area. In order to determine that area, I have to determine this area and subtract this area. So from the area under the function above, so let's say between 1 and 10. So the area will be the integral from 1 to 10. I have this area which is under f of x minus subtract this area which is under g of x. So what we normally say, from the function above, we subtract the function below. But what we are really doing is we are calculating this area from positive 1 to 10 from f of x dx, and subtract this area from 1 to 10 from g of x dx. So again, the green area, all this is the integral from 1 to 10 from f of x dx, and this integral, this area, is the integral from 1 to 10 from g of x dx. So from the big area, I subtract the small area to get this piece. So again, in general, we say from a function above, we subtract the function below. Is that better?
Yeah.
So therefore, from the function above, I subtract the function below, plus from the function above, I subtract the function below. But of course, when I subtract, I have to change all symbols to the opposite symbol. When I subtract, I have to change all symbols into the opposite symbols. Is this okay so far?